Welcome everybody to Algebra 1, Section 4.4, Zeros of Functions. So first of all, let's talk about what are zeros. So zeros are one of two things, depending on whether we're talking about graphically or algebraically, and they're really one and the same. It's just two different ways of thinking about it. So graphically, or on a graph, the point or points, so that S goes in parentheses, could be singular or plural, at which the graph crosses the x-axis. And then another way to think about the same thing is algebraically, or in an equation. Blanked on how to spell algebraically for a moment there, I apologize. It would be the point or points, so again using that S in parentheses, at which f of x or y equals 0. And so we're across the x-axis, and for it to cross the x-axis, remember the x-axis is our horizontal axis. In order for it to cross this axis right here, the y value must be 0, the f of x value must be 0. If the f of x or y value is anything else, such as 3, it couldn't cross the x-axis. It'd have to, if it was negative 3, it couldn't cross the x-axis, but if it's a positive, if it's at 0, it could. Now, what are they also called? So other words for these are x-intercepts, for example, where it crosses the x-axis. They're also called roots or solutions. Sometimes they're called solutions as well. So identifying them given a graph. So we're trying to figure out where to cross the x-axis. Well, right here is where it crossed the x-axis. So what's the x value? The x value is 2. Now we know the y value has to be 0, the f of x value has to be 0 on all of these, which is we already talked about. So we can just list x equals 2 and call it good. On number 2, there's 2 of them. It crosses the x-axis here and here. So you can list them as 2 separate ones, x equals negative 2, x equals 1, call that good. Or you could list it as x equals negative 2 comma 1, 2 different ones. Now, in the same equation there. Now notice, I didn't put a parenthesis around that because it's not an ordered pair. They're 2 separate numbers just in a list. Number 3 through 6, I'd encourage you to find them on your own. So number 3 here would be right here, x equals 4. Sorry, try that again, x equals 3. On number 4 would be these two values, x equals negative 4, comma 1, or 2 separate equations, x equals negative 4 and x equals 1 is fine as well, or a list like I did. On number 5, we have negative 1 and 5, so negative 1, comma 5 is how I usually write it. And on number 6, we have 3 different ones. So x equals negative 5, 0, and 3. Now typically if you do a list like I just did here, you go least to greatest. Don't technically need to. I'm not going to count it wrong if you don't, but I would encourage you to if you're going to do the list. That's what I would do. Now let's practice finding them algebraically. We're going to do some math. So these are going to be from equations here from 11 through 12. And so step 1 is that we replace y, or f of x, I'm going to put a slash there because they're the same thing, with 0. Step 2 is that you solve for y slash f of x. So on number 7 here, we're going to replace this with 0 and do 0 equals 4x minus 8. The reason we're able to do that is because we said it has to cross the x-axis. In order for it to cross the x-axis, the y or f of x value has to be 0. So we make it 0 and then solve our equation. So I'm going to add 8 to each side to solve this equation. And I get 8 equals 4x. Now I'm going to go ahead and divide both sides by 4. And I get x to equal 2. I continue on to do the same thing on each of the next 5 problems. I'd encourage you to go ahead and try these. Hopefully you've already attempted number 8, but here it is. We replace f of x with 0 and get 0 equals 2x plus 2. Start solving by subtracting 2 on each side, and we get negative 2 equals 2x. I'm going to divide both sides by 2, and I have my x equal to negative 1. On number 9, once again, replacing f of x with 0 or the y value with 0, it's the same thing. Here I could either subtract 7 or I could add x. Either way, you're able to get the correct answer, but I like to keep it positive. And x equals 7. And I already have it solved. Had I subtracted 7, I'd have to go to an additional step to multiply or divide both sides by -1. Number 10 here, 0 equals 2/3 x minus 6. Add 6 to both sides. 6 equals 2/3 x. Then multiply with the reciprocal on both sides of 3/2. Look to cross reduce with the 6, and it becomes 1 and 3, and I get 9 equals x. With the right side reducing, in case you didn't realize that. On to number 11 here. Replacing f of x with 0 again, and we have 1/2 x plus 2. Subtract the 2 on both sides, and I end up getting -2 equals 1/2 x. Multiply by the reciprocal, which is 2 or 2/1. Those reduce, and I get x. On the other side, as I multiply by 2 or 2/1, I get -4. On to number 12 here, -2/5 x plus 4. I replace f of x with 0, and I end up getting -2/5 x plus 4. I'm going to add 2/5 x to make my life a little bit easier by keeping my numbers positive, but you could also just as easily subtract the 4 and it'd be fine. 2/5 x equals 4. Multiply by the reciprocal on both sides, 5/2. Had you subtracted 4 on both sides in the previous step, you'd be multiplying by a -5/2 in this step. And you get x equals, so I reduce the 4 and 2 to 2 and 1, x equals 10. Now, we're going to find these next ones graphically, 13 through 22, but you notice we don't have a graph, so we have to type these in a graphing calculator. So we're going to hit y equals to enter the function, and then hit graph to view the graph. So on number 13, when it's f of x equals x squared minus 16, I'm going to go over my handy Calc 84, and if I was at the home screen, main menu, it would look just like this. And so the top left, right above that green second button, I see the button that says y equals, so I click that button. And as I click that button, I held it there, but let me just click the button. I can see I can type in this first one, x squared minus 16. Now the x button is directly diagonal to the second button, diagonal down and right to it. It's this dark button I just spammed a bunch so you can see it. As I accidentally hit the ass button in there as well. I didn't mean to hit apps there. I want to make sure I emphasize the P's. But anyway, and then the second button would be right here that I'm spamming right now. So you can see that adds on an exponent of 2. And let me delete those as well, because we don't need those. And then we just type this in. Oop, I still need the x though on this, so I better type that in. There we go. And then I have the second one already typed in as well for number 14, but I toggled that one off. So now as I go to graph at the top right, I can see this graph, and I can see it crosses the x-axis at -4 and 4. So those are my two answers here, -4 and 4. So I write those down. X equals -4, 4. And now I go ahead and graph 14, which once again I already typed in 5x squared plus 5x minus 30. So I go back to my y equals. I toggle this graph off and the other graph on because I already typed it in. I go to graph, and I look at this graph, and I can see it crosses at -3 and +2. So those are my two x-intercept zeros, roots, or solutions, whatever we want to call them. So I write them down. X equals -3 as well as 2. Now, Calc 84 restricts you to only typing in 2 functions at a time. So I'm going to go ahead and type in my next 2 functions. Oh, hold on, please. So I have to go back to Calc 84. Typing these in. It gives me as occasionally, but I'll just X out of those. And as I type in my next one, I have -x squared minus 2x plus 24. And while I'm here, I'm just going to go ahead and type in the one for the next one as well on number 16, which is x squared plus 7x minus 8. Toggle that second one off though, so we can just look at the first one. And we notice it crosses the x-axis at -6 and 4. So my two answers on 15 are -6 and 4. I close that so I quit clicking on that on accident. And I end up having x equals -6, 4. Now going back to number 16, which I already graphed, or already plugged in to f of x. So I just need to go back and go to y equals, and toggle this one off and this one on. And I'll go ahead and clear that first one out because I'm going to be changing it in just a moment anyway. And I see I have -8 and 1 as I moved my graph over a little bit. And so I'm going to write those two down. X equals -8, comma 1. And now I'm going to go ahead and type my next two at the graph, 17 and 18. And so I'm going to go back to y equals. I'm going to type this in. So on 17, it is x squared minus 3x minus 28. And on the second one, on number 18 here, it would be -x squared. The negative is listed at the bottom in the parentheses. That's important to note. Plus 7x minus 10. Toggle my second one off so I can look at 17 and not 18. And go to graph. And I can see it's at -4 and 7. So those would be my answers on number 17. Now I'm going to go to 18. And as I turn my second graph on and my first graph off, and go ahead and clear out my first graph knowing I won't use that anyway again, I see it crosses at 2 and 5 on the x-axis. So my answers are 2 and 5. Now on number 19, I notice I have a power of 3 now. So that's going to impact how I type this in a little bit. I will showcase what we do. So I go back to y equals, and on my first one here, I'm going to go and toggle this graph on, knowing that I'm going to use that graph. It's going to be x cubed, so I'm going to have the x button. And now for my exponent, instead of hitting square, there's no button for cube. And so it's right above the division symbol, this button I'm clicking right now, where it has this caret symbol. And I'm just going to go and clear that out and retype it in, x caret, and type in 3. To get out of this, so I have to hit that right arrow at the top right. So I'm going to hit that right arrow, which you just saw darken up right there as I keep hitting it. And so after I'm to the right of the 3, but down on the normal layer, not up for the exponent, but down on the normal layer there, I continue typing this function in, which is minus 5x squared plus 2x plus 8. Then I type in this next one, also an x cubed, so I go x caret 3 for x to the power of 3 plus 2x squared minus 15x. Toggle the second graph off so I only have one graph at a time so I can see what I'm doing. And I notice I have 3 answers here. I have -1, 2, and 4. So I'm going to write those down accordingly. X equals -1, 2, and 4. Back to the second graph on number 20 here. I once again have 3 answers, -5, 0, and 3. So I write them down, x equals -5, 0, and 3. And now I plug in my last two for 21 and 24. So I go to y equals, I clear this one out. I'm going to go and start typing in 3x to the third power minus 3x. My second one, clear it out, and I type in x to the fourth power. So I still use that caret. Any power greater than 2, we have to use that caret. You can use it for the power of 2 as well, even though there's a button for that just for the x squared, because it's more common. Plus 2x cubed minus 25x squared minus 50x. It's a long one. I'm going to turn number 22 off and turn number 21 on, and go ahead and graph. And on number 21, I see it crosses the x-axis thrice, 3 times at -1, 0, and 1. So I have x equals -1, 0, and 1. And now to my last graph. I look at the one for number 22 as I go back to the y equals screen. And it crosses 4 times at -5, -2, 0, and 5. I write these down. And that's my answer. So we found zeros graphically by seeing where it crossed the x-axis, algebraically by finding where it crossed the x-axis by plugging in 0 for f of x or y and solving for x. And then use graphically again using a graphing calculator. And that wraps up section 4.4.